In this video, we will apply source transformation to the analysis of a circuit. The circuit shown has a 5 ampere independent current source, and we have to calculate the voltage V on the extreme right side of the circuit across the 10 ohm resistor. Looking at the left-hand side of the circuit, we can identify a current source in parallel with the resistor, which is enclosed in a box to indicate the circuit that we will be transforming. The two terminals coming out of this box. Recall that a current source in parallel with the resistor can be converted into an equivalent voltage source in series with the same resistor value. The two terminals to which it is connected is terminal A and D, and the value of the voltage source will be the product of the current with the resistance value, which will give us 150 volts. Note that for the circuit on the top, which is the current source with the resistor in parallel, if we do not connect anything to the circuit, then node A will be positive with respect to D, and we should get the same behavior from the transformed circuit. Looking at the circuit at the bottom, we note that the top end of the voltage source has to be positive with respect to the bottom end for node A to be positive with respect to D. This completes the source transformation from a current source in parallel with the resistor to an equivalent voltage source in series with the same resistance. We will connect the rest of the circuit to this transformed circuit. Note that the 30 ohm resistor is in series with the 7.2 ohm resistor, and these two resistors can be combined into a single resistor to give us another equivalent circuit, which will be the following. We notice that the voltage source is in series with a resistor of value 37.2 ohms, and we can do source transformation on this portion of the circuit to convert it into an equivalent current source in series with a resistor. Source transformation of this portion of the circuit will give us a current source in parallel with the same resistance value. The value of the current source will be the voltage divided by the resistance value, or 150 divided by 37.2. The current direction through the source will be pointed upwards so that we get the same behavior from the transformed circuit as the original circuit. For example, if nothing is connected to the transformed circuit, then the top end of the 37.2 ohm resistor will be positive with respect to the bottom end, which will be the same behavior as we will get from the previous circuit. We will connect the remainder of the circuit and get. If we want, we can continue this process and do some more source transformations to be able to calculate the voltage V. However, we notice that the current source is divided into three different paths and three currents, which can be denoted as I1, I2, and I3. And using the current division principle, we will get that I3 will be equal to conductance of the elements through which I3 flows, which will be 1 over 6 plus 10 ohms, divided by the sum of all the conductance in the three parallel paths, which will be, and multiplied by the current source value. Calculation of this expression will give that I3 is equal to 2.4 amperes. And the voltage V will be equal to 10 times I3 will be equal to 24 volts. This completes the analysis of this circuit, where we used source transformation to simplify the circuit and calculate the voltage V that was required. Next, we will take an example of source transformation with controlled sources in the circuit. The circuit shown has a 5 volt independent source in series with a 2 ohm resistor and a voltage control current source that depends on the voltage Vx. We note that the 5 volt source is in series with a 2 ohm resistor, and we may be tempted to convert this into an equivalent current source in parallel with the same resistor, and the portion of the circuit which is enclosed in a box is indicated, and we are trying to transform this portion of the circuit into an equivalent current source in parallel with the resistor. There are two nodes coming out of this dotted box, which is connected to the rest of the circuit. We cannot apply source transformation to this part of the circuit simply because we have a control source that is partially inside the dotted box and partially outside. For example, the controlling variable Vx is inside the box and the controlled source is outside the box. Recall that for equivalent circuits, we have to have the element entirely inside the box or outside the box, and hence we cannot apply source transformation to the circuit inside the dotted box. We will delete this selection and choose a different portion of the circuit where it is possible to apply source transformation. Suppose we choose the following portion of the circuit and enclose it in a dotted box to indicate what is inside the box and what is outside. And we have two terminals coming out of the dotted box. Also note that there is no control source that is partially inside the box and partially outside the box. The entire control source is inside the box. Inside the box, we have a voltage controlled current source in parallel with a 3 ohm resistor, and we can apply source transformation to this portion of the circuit. The source transformation will give us a 2 ohm resistor with the controlling voltage Vx across it in series with a 3 ohm resistor, which is coming from the transformed source, and connected to a voltage controlled voltage source of value 6 Vx, with the top end of this voltage source as positive to give the same behavior as the current source in parallel with the 3 ohm resistor. And we can connect the rest of the circuit that is outside the box to this portion, and we will get the 5 volt source connected. This is an example of a valid source transformation, and although currents and voltages inside the dotted box will be different from the previous circuit, the voltages and currents outside the box will be the same between the two circuits. To summarize, we have to be careful when applying source transformation to controlled sources and make sure that the controlled source is entirely inside the box that is being transformed and not partially inside and partially outside.